Emission Engineering presents EVEN, the next level of furnace operation. Hello and welcome to Emission Engineering. This is a short summary of our extended video, also available on our website. What is EVEN? Let's have a look here. The major objective in oil refinery fired heaters is to heat up a feed stream till a desired outlet temperature for a downstream process, which can be a distillation tower, a reactor, or other equipment. The more uniform heating inside the firebox occur, the better for the process and the less operating problems will occur. Furnace manufacturer design the firebox, and as a result, the number of burners and the heat release per burner is determined. It is the desire not only of furnace manufacturers, but as well of those that run furnaces, that the flue gas temperature of each burner is the same, because then the heat transfer to the tubes is even. But uniform flue gas temperature asks for uniform air-to-fuel ratio in all burners. So far the theory. To achieve this in practice means one need to overcome several problems. Whereas fuel distribution is normally not an obstacle, a highly underestimated reason for non-uniform temperature profiles and heat flux inside the firebox are non-uniform air-to-fuel ratios. On a system with forced drive burners, like here on the slide, the combustion air very often distributes non-uniformly throughout the combustion air ductwork. A major problem is that the distribution is not even measured at all. On systems with natural drive burners, where there is no air ductwork, one has the same problem of adjusting each burner air damper in such way that the air-to-fuel ratio is the same in each burner. EVEN is the solution for overcoming all these problems, because the furnace optimizing tool is indirectly measuring the airflow to each burner by measuring and displaying the pressure drop caused by the airflow through each burner throat. Like this, the operator can instantly see how the airflow to each burner is. The main advantages of being able to measure and correct the fuel-air ratios more accurately are: 1. Less in- and external coke formation of the feed tubes and less tube wearing. 2. More even flame shape among all burners. 3. Safer operation compliance with the safety norm DN EN 7462 and API 535 and 556. DN 7462, for example, requires the air-to-fuel ratio in every burner to be in a certain envelope, something that most fired heaters not comply with at all. 4. More even heating resulting in less hotspots. And 5. More even feed outlet temperature in each feed pass. And 6. More even flue gas temperature and oxygen content of each burner. And 7. Oxygen analyzers measure more representative. And 8. Easier control of emissions, specifically NOx. And 9. Less problems with flame instability of individual burners, as all can be operated in the same air-to-fuel envelope. 10. Easier to adjust the furnace for the operators, as there is a measurable criteria instead of simply judging the flame shape based on experience and visible appearance. Besides, that leads to time savings for operators. 11. Burner airflow can be also adjusted during startup of the heater, leading to safer and more controlled conditions during that phase when the DCS has not yet taken over control mechanisms. What is actually measured with EVEN? EVEN measures the pressure drop of combustion air through each individual burner throat. Like this, burners that are operating with the same heat release are easily operable at the same air-to-fuel ratio. But not only that, also if the burners are firing on different heat releases, this is possible. Besides the mentioned technical advantages, there are of course economical ones, and they can be impressive. Of course, Potential saving depends on the size of the refinery, concerning the heat release to all furnaces, and the real average oxygen content in the flue gas. In our experience, most fired heaters have the potential for further excess air reduction, here highlighted in green. Even a small reduction can quickly lead to savings in the 7-digit range. Considering that fuel costs are quite significant in the process of processing crude oil and the resulting products, the return on investment in this area is very quick because our tool can be implemented easily. Finally, a few last words about the hardware used by our optimizing tool EVEN. We have developed different versions. Version 1 is a totally non-electrical pressure drop measurement device. It can be applied in non-classified areas as well as in explosion areas. It is very inexpensive, but has a disadvantage that the pressure drop are accessible only locally at the furnace. The delivery time is approximately 2 to 3 months. Version 2 works with pressure differential transmitter and is used by us when we travel on site for temporary measurements. Version 3 has transmitters, a PLC designed for safe area, and a human-man interface, normally located near the furnace and can be delivered for explosion-proofed areas. Via interface it can be linked to the DCS. This version is for permanent implementation. Delivery time is 4 to 5 months. Finally, version 4 is similar to version 3, but it automatically controls each burner air damper based on pressure drop. That requires control dampers, actuators, positioners, etc. on each burner and each air damper. The cost of this version is significantly higher than the cost of version 3 and even more so compared to version 1 or 2. All versions of EVEN can be instantly applied to a running heater without the need for a furnace shutdown. The return on investment is so great that EVEN pays for itself in less than 2 to 4 months. The furnace optimizing tool EVEN is patented by Emission Engineering. You are interested in EVEN? Feel free to contact us. Here are our contact details. Thank you for your attention. Emission Engineering. We engineer your emissions.